A happy and a pleasant morning to you all children. I hope you are all keeping fit and you are enjoying your corona holidays. At the same time, I also believe that you are engaged more than the usual because the lessons are being sent to you every day and hope you are all tracking the lessons in time and doing the homework on time. Okay, children, we all started with the basics with the chemistry and symbols is crisscross of writing the formula of compounds. So all this I hope you are familiar with. Still, if you are lacking, you can repeatedly listen to the slides till you get understand and call me for any doubt. Now in today's class we are going to see the basics how chemistry has evolved and who are the scientists behind it and what were the laws given by him. So we are going to study about the early stage of the evolution of chemistry through the two laws. So we will go up into the lessons. Come, we will go.
Now, look at this picture, children. He is a very prominent chemist who lived in the year 17th century. And he is known as father of modern chemistry. And who is that? He is Antony L. Lavoisier. Antony Lavoisier was born on 26th August 1743 and died on 8th May 1794. He was a French nobleman and a chemist. He is considered as father of modern chemistry and was a French nobleman prominent in the histories of chemistry and biology. In 1783, he was the first person to succeed in determining the composition of water. So Antony L. Lavoisier laid the foundation of chemical science by establishing the two rules, which are the two basic rules in chemistry, which we are going to see in detail.
The two laws of chemical combination given by Lavoisier, they are law of conservation of mass, law of constant proportion. Law of conservation of mass and law of constant proportion. So we'll learn about this in the upcoming slides. Here is the law of conservation of mass. Antony L. Lavoisier, a French scientist, established the theory of law of conservation of mass. The statement given by him is very important. The second part of the slide. The law of conservation of mass states mass can neither be created nor destroyed in a chemical reaction. So what is the statement? Mass can neither be created nor destroyed in a chemical reaction. So that means mass is conserved. You cannot change the mass when the reaction is taking place. That is the simple logic behind it. So the statement is mass can neither be created nor be destroyed in a chemical reaction. This slide gives the proof of the law of conservation of mass that we had seen. So it is an activity based and practically oriented law verification. Okay, it's a very important practical activity question, anything you can say, as far as Cbse examinations are concerned. So it's a very important topic. A 5-mark question. State and how will you verify the law of conservation of mass? So already we have stated, again let it be. The statement is mass can neither be created nor destroyed in a chemical reaction. This means that during a chemical reaction, the sum of the masses of the reactant and the product remain unchanged. So what is the meaning of this? So if a chemical reaction is taking place, we need at least two chemicals to get mixed up. That we call it as reactants. And after these two chemicals mix up together, they give a product entirely new from the reactants, and we call it as products. So reactants, when we write a chemical reaction, reactants will be on the left side and there will be an arrow, and after the arrow you will find the products. Okay, so the reactants and products. The chemical properties of the reactant will be entirely different from the chemical properties of the product, because the product formed is an entirely new one. Now in the same way, we will do the experiment and just look at the diagram here. There is a conical flask, and inside the conical flask there is a test tube, and in the conical flask sodium sulphate Na2SO4 solution is being taken, and in the ignition tube or the test tube barium chloride solution is being taken, and this test tube has to be carefully inserted into the conical flask, taking care that the two solutions do not get mixed up, and it is done with the help of a thread. So a thread is tied on the neck of the test tube and carefully inserted into the conical flask where we have taken sodium sulphate solution. Now keep these on the weighing pan and measure the mass of both these. You have to be observed that the two solutions are not getting mixed up, right? So when these solutions are not getting mixed up, they are the reactant, and measure the mass of it. So the balance is 300.23 grams. Now take out the flask and tilt it. When you tilt it, the two solutions gets mixed up each other, and so the reaction takes place. And as an indication of the reaction taking place, you can see a precipitate. Precipitate means a cloudy or curdly like a suspension can be seen. Now it ensures that the reaction has taken place. Now after the reaction takes place, keep the same flask on the pan and measure the balance, and the mass again shows 300.23 grams. It means the mass of the reactant is equal to mass of the product. So let us go through the activity what is given here. Take some sodium sulphate solution in a conical flask and some barium chloride solution in an ignition tube. Hang the ignition tube in the flask by a thread and put a cork on the flask. Find the mass of the flask on the balance. Then tilt the flask. A chemical reaction takes place and the sodium chloride and barium sulphate are formed. Then find the mass of the flask again. It will give it will be seen that the sum of the masses of the reactant and the product remains unchanged. So by this we can establish the law of conservation of mass. That means mass before the reaction is equal to mass after the reaction. That means mass is conserved. Law of constant proportion. Law of constant proportion states that a chemical compound always contains exactly same proportion of elements by mass. So the statement is law of constant proportion states that a chemical compound always contains exactly the same proportion of elements by mass. This law is known as law of definite proportion. Joseph Louis Proust gave this law, hence this law is also known as Proust law. Now let us see the law of constant proportion in detail. The law of constant proportion states that in a chemical compound, the elements are always present in the definite proportion by mass. So it gives a vague statement and you will be able to understand only when we see the examples. Now let us take the compound water. So the compound water, the molecular formula is H2O. Okay, so here two molecules of hydrogen combine with one molecule of oxygen and it makes the compound water H2O. So that's what it's being given here. Water H2O always contains two elements, that is hydrogen and oxygen, combined together in the same ratio 2:16. How did we get this 2 and 16? It is the atomic number. So atomic number of hydrogen is 1. Here two molecules of hydrogen, therefore 2 into 1, 2. And the atomic number of oxygen is 16. So 2:16. And when you simplify this 2:16, you get 1:8. So by mass. Okay. So water H2O combines with two molecules of hydrogen and one molecule of oxygen, and when we simplify the ratio, we get 1:8. So how many parts are there in 1 plus 8? 9. So if 9 grams of water is decomposed, okay, if 9 grams of water is decomposed, we get 1 gram of hydrogen and 8 gram of oxygen. That is the reverse of this. Okay, so that's what the statement says. In a chemical compound, that means in water, the elements, that is hydrogen and oxygen, are always present in the definite proportion, that is 1:8. Similarly, we can take the next compound to be ammonia NH3. Here nitrogen, 1 part of nitrogen combines with 3 part of hydrogen to give ammonia. So ammonia always contains two elements, nitrogen and hydrogen, and they combine together in the same ratio 14:3. How did you get this 14? The atomic mass of nitrogen is 14 and that of hydrogen is 1. Here 3 molecules of hydrogen are there, therefore 14:3 by mass. Okay, so this is how the law of constant proportion is explained. So what is the statement? In a chemical compound, and the elements are always present in a definite proportion by mass. Here is another scientist, John Dalton, who is supposed to be a well-versed chemist, physicist and whatnot. So he has given the fundamental basics for the molecules and atoms. John Dalton, his lifespan is between 6th September 1766 to 27th July 1844, was an English chemist, meteorologist and physicist. He is best known for his pioneering work in the development of modern atomic theory and his research into color blindness. So, his contribution to chemistry is very vast, and let us see what he has given to atoms and molecules as far as the class 9 is concerned. This slide is a very important slide for the knowledge wise as well as the examination part of view also. So this is known as Dalton's atomic theory. So what were the contributions that Dalton has given for the chapter atom? So we call it as Dalton's atomic theory. First point, matter is made up of tiny particles called atom. So when you take any matter, it is made up of tiny particles called atom. Second, atoms are indivisible. That means you cannot further divide it. Atoms are indivisible and cannot be created or destroyed in a chemical reaction. Right? Third point, atoms of a given element are similar in mass and properties. So when you take the atoms of an element, they are similar. That means they have the same shape, same size, same weight. Everything will be similar mass, and also the properties will be the same. Fourth point, atoms of different elements have different mass and properties. Naturally, when you take atoms of two elements, hydrogen and oxygen, their masses will be different as you had seen in the previous slide, and they will have their own properties, therefore different properties. So atoms of different elements have different mass and different properties. Fifth point, atoms combine in a small whole number ratio to form compounds. That's what we have seen, law of constant proportion. So atoms combine in a small whole number ratio to form compounds. So we have seen 1:8 for water and 1:14 for ammonia. The last one, in a given compound, the relative number and kind of atoms are constant. The relative number and the kind of atoms will be the same for a compound. So these 6 points are very important points, and they are known as postulates of Dalton's atomic theory. Postulates of Dalton's atomic theory. Let us study about the atoms, which we have already dealt with. What does this slide tell us? An atom is the smallest particle of an element that may or may not exist independently and retain all its chemical properties. Atoms are very small in size and smaller than anything we can imagine or compare with. Atomic radius is measured in nanometer, and the symbol for nanometer is nm. 1 nanometer is equal to 10 to the power minus 9 meters. So when you divide 1 meter with 1 followed by 9 zeros, what the result that you get is a nanometer. Okay. Then example, the atomic radius of an atom of hydrogen is 10 to the power minus 10 meters. The radius of molecules of water is 10 to the power minus 9 meters. So what does we conclude from all this? An atom is the smallest particle. It cannot be divided further, and the dimensions of an atom are very small, and it is expressed in nanometer, and 1 nanometer is equal to 10 to the power minus 9 meters. This slide is a repetition of what I had given you in the last classes. Symbols of atom of different elements. The symbols of elements are represented by letters. The symbols of some elements are represented by one letter, and the symbols of some elements are represented by two letters. If the symbol has one letter, it should be written as capital letter, and if the symbol has two letters, then the first letter should be capital and the second should be small. So all this you know because already you have encountered with this. So aluminum Al, argon Ar, barium Ba, boron B, bromine Br, calcium Ca, carbon C, chlorine Cl, cobalt Co, copper Cu, fluorine F, gold Au, hydrogen H, iodine I, iron Fe, lead Pb, magnesium Mg, neon Ne, nitrogen N, oxygen O, potassium K, silicon Si, silver Ag, sodium Na, sulfur S, uranium U, zinc Zn. So these are the very important frequently encountering elements that at any cost you have to know the symbols. Now let us see what a molecule is. A molecule is the smallest particle of an element or compound which exists independently and shows all the properties of that substance. So hydrogen is an atom, we can say, and oxygen is an atom. When hydrogen, two part of hydrogen combines with one part of oxygen, we get a molecule of water. So there will be so many molecules in the water, and one such molecule, if you take, a molecule is a smallest particle of an element or compound which exists independently and shows all the properties of that substance. A molecule is a group of two or more elements and are held together by attractive forces. Atoms of the same element or different element can join together to form molecules. So these are the basics about the molecules, and you can see the structure of the molecules form. Here nitrogen, when we write nitrogen, we write N2, it's a diatomic molecule. Oxygen, we write O2. So oxygen and oxygen, they are the same elements. Nitrogen and nitrogen, they are the same elements. Okay. And similarly, when we take chlorine, we say it has Cl2, we write. That means it has two atoms of chlorine. Okay. So these are all with the same elements. Now, as we have taken water, H2O, then carbon dioxide, CO2, nitrogen oxide, NO. So here two different elements combine to make a compound. So whatever may be it, then the molecules are held by a very strong interactive forces between them. This is an important slide which tells more about the molecules of an element, whether it belongs to monoatomic, diatomic, triatomic, tetraatomic and polyatomic. So monoatomic means the atomicity is 1. Diatomic, then the atomicity is 2. So let us look into the examples one by one. Argon, Ar we write. So it has only one atom. Therefore, we call it as monoatomic. Helium, He, only one. Therefore, monoatomic. As we have discussed, oxygen O2, hydrogen H2, nitrogen H2, chlorine Cl2. See, all these have two atoms. Therefore, they are said to be diatomic. Phosphorus, we write it as P4. So, the atomicity of phosphorus is 4. And similarly, S8, sulfur is S8, we call it as polyatomic. Okay. Like this, we count the atomicity of the different elements and compounds. Now, what does the slide say? Molecule of an element contain atoms of the same element. Molecules of some elements contain only one atom, and the molecules of some elements contain two or more elements. So atomicity, what do you know as atomicity? Atomicity is the number of atoms present in one molecule of the element. So this is a very important slide which tells you about the atomicity. So this slide gives the molecules of the compounds. See to the examples in the slide. Water H2O, ammonium NH3, carbon dioxide CO2, hydrochloric acid HCl, nitric acid HNO3, sulfuric acid H2SO4. So when you take water, what are the combining elements? It has H2O, H for hydrogen, O for oxygen. Similarly, ammonium NH3, N for nitrogen, H for hydrogen, carbon dioxide CO2, C for carbon and O for oxygen, hydrochloric acid HCl, H for hydrogen and Cl for chlorine, nitric acid HNO3, H for nitrogen, N for nitrogen and O for oxygen, sulfuric acid H2SO4, hydrogen, sulfur and oxygen. Now, the number of atoms in the each cases, when you take water as H2O, there are 2 atoms of hydrogen and 1 atom of oxygen. When you take NH3 ammonia, 1 atom of nitrogen and 3 atoms of hydrogen are being placed. So similarly, you can see to the remaining with the help of the tabular column. Children, by this we end today's learning. So here we are in the last slide of today's class. So again I repeat you, what you have seen in class 9 regarding chemistry is very basic. The basics are very important, and so save all the files of mine, chemistry, and get repeatedly hear that. That alone will make you to master it. Right? So listen as frequently as possible all these slides regarding the chemistry lessons, because they are the fundamentals. When you go for your higher studies, even in the colleges, this knowledge will enhance you for a better understanding. So learn the basics very thoroughly, and so literally we have completed 3 lessons in chemistry so far, right? So next week I will take up physics with a new lesson, and today's homework, very important, today's homework, nothing to write in your classwork but the symbols and the crisscross. You have to write it as home test, and you have to send it to me, to my personal number. And as usual of today's learning, you will send me the feedback, right, like viewed the PPT with audio, and you will send it in the group. So there is no classwork, The homework will be the same, the symbols of elements and the crisscross. This you have to write it as a home test and you have to send to me. So again I am telling you children, be in constant touch with the symbols and the valencies. If you lack these two, I am damn sure you will not advance in chemistry. So this is the right time, this is the right place, and this is the right season. The corona holidays, I mean, is the best. So you get ample time for brushing you up and for revising, and so make use of the time. Don't be lenient and don't be lazy also. Okay children, all the best. We'll meet in next week class. Until then, bye bye from you.